All right, greetings, students. It's Monday, July 3rd. So if you haven't noticed, I'm not in class today. So today we're going to be doing a video lecture, continuing where we left off. I think all of you were here on Thursday, so I hope you had a great weekend. Happy Monday. On Thursday, I passed out a packet starting with Chapter 2. So we thus far we have completed Chapter P, what we're going to do, and Chapter 1. So today we will be moving into Chapter 2, beginning with Section 2.1, Quadratic Functions. So if you have questions, stop me at any time. We can stop things and answer the questions. Otherwise, we'll just proceed with this material. Other announcements. So be sure that you're on top of the online assignments. If I haven't done so already, I've been opening up all assignments for the semester. The homeworks will be up first, and also there should have been a quiz over the weekend. So just make sure that you're getting those online assignments turned in on their due dates. More than likely, I've made everything due at exam 2, which is like the 20th. No, I think it's like the 13th of July. So it's like 10 days from today. But so just stay on top of the online assignments on Pearson My Lab and Mastering. And the due date for these assignments is going to be the time that we take exam 2. So as soon as we start exam 2, these assignments will be due. Now the assignments also should be open until we take the final exam, because I want you to use this material to study from. So it'll be open and you can take a look at it. So Chapter 2, Section 2.1, we're going to be looking at quadratic functions. So let's see. So it's day 10. It's Monday, July 3rd. It's 1 p.m. So in this section, we study quadratic functions, which are polynomial functions of degree 2. Okay, so a quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers with a not equal to 0. We call this quadratic functions. The graph of any quadratic function is a parabola. By parabola we mean like a U-shaped graph, and it typically opens either up or down. So then we want to start with the standard form of a quadratic function. So the quadratic function f of x equals a times x minus h quantity squared plus k, where a is not 0. We call this a quadratic in standard form. So the graph of f is a parabola where the vertex, oh no, found a mistake. Start over. Okay, I'll just note it and I'll make the change later. I'm gonna keep moving. Okay, where the vertex is going to be h comma k, so that's supposed to be like this. Okay, so let's see. The graph of f is a parabola where the vertex is h comma k. Now the parabola is symmetrical with respect to the line x equals h, and this is called the axis of symmetry, or the axis of the parabola. So when we start looking at parabolas and graphing them, they're symmetric. So and remember the discussion we had on symmetry. So symmetric is you can cut it in half and fold it. That's the symmetry about the middle, and that's the kind of symmetry that we're going to be using when we're talking about parabolas. So if you think of a parabola, it has I'll do a quick sketch. So say we have some xy plane, and the parabola generally makes a shape like this. So when we say it's symmetric, we can cut it in half, and then any point on the parabola is going to be equidistant from another point on the opposite side of this axis. Okay, so whenever we have x comma y, we also have negative x comma y. Yeah. So we get a point on the right, it gives us a point on the left of this purple line, which we call the axis. Anyway, I think it's not too bad to see that, and we'll see it. Okay. So then continuing, if our A is positive, then the parabola is going to open upward. Okay, so we've actually been doing this intuitively as we've been discussing some of these problems. Because I'll say, what kind of shape is it? And you'll see it's a degree 2, and you'll say it's a parabola. And then I'll ask, which way does it open? And you guys have actually been getting it right. When the leading coefficient was positive, it was opening up, and you tend to get it correct. And then when the leading coefficient is negative, or in other words, when our A is negative, you all have been catching it and saying that the parabola opens downward. So that's what this second to last paragraph, or this last paragraph before example 1 is saying. If your A is positive, then the parabola opens upward. If the A is negative, the parabola opens down. If A is positive, K, so think about it. Say we have a parabola, say it opens up. If the parabola is opening up, are we going to have a maximum value or a minimum value? So in order for it to be the max, it has to be bigger than any other y value, right? So going up and down, is there a max or a min? So if the parabola opens upward, then there should be no max, and we're going to have a minimum value. So then the k is going to be our minimum value for this from this function. And then if the parabola opens downward, so if our a is negative and it opens downward, then k is going to be our maximum. So if the parabola is opening down, then we have a max on top that we're considering. Okay, so that comes into play when we start maximizing quadratics, maximizing or optimizing quadratics. So if we look at this example 1, that's the one I was missing. Okay, no, there was another menu, but anyway. Okay, so this example 1 says writing the equation of a quadratic function. All right, so it says find the standard form of the quadratic function f whose graph has the vertex -2, -1 and passes through the point -3, 1. Does f have a maximum or minimum value? So it says find the standard form of the quadratic function. We're given the vertex and a point on the quadratic. So now, what's the suggestion whenever we use a formula in class? Okay. So the suggestion is whenever we use a formula, write it down. So it's asking us to say, find the standard form of the quadratic function. So if we want the standard form of a quadratic, we should write it. And again, this repetition helps to ingrain it into our memory. So every time we use it, no matter the time or place, write it. So the standard form is going to be f of x equals a times x minus h squared plus k. Okay. Where h and k is going to be the coordinates of our vertex. My time is about up. I got a minute on this, but it's okay. All right, so let's see. So we want to get it into this form. As we go, it says the vertex, f whose graph has a vertex of -2, -1. So if that's the vertex, that's our h comma k. So that's the coordinates of our vertex and passes through the point -3, 1. So we can use this for our x and y right now so that we can solve for anything that's missing. So let's plug these into our formula and see where we are. So now the f of x is our y, so that has a value of 1 right now. A, we haven't identified, so we just bring it down. X is -3. H is -2. Notice how I wrote that, because I said minus a negative. Quantity squared, and our k is -1. Okay, so now it looks like the only variable we don't have is a, so we can actually solve for a, our leading coefficient. So then we'll get 1 equals a parentheses, that becomes +2, so that's -1 squared is 1, -1, add 1, so then a is 2. Okay, so now if we want the equation, we want to say keep the x and the y, so then f of x is going to be 2 times x plus 2 squared minus 1. So this should be the equation of the parabola. Let me see. So it says find the standard form of the quadratic whose function has this vertex, so x minus a -2, and then the k is the minus 1, and it passes through the point -3, 1. So to verify this, we could graph it. Yeah, we could graph it, and let's look at it, and verify that these things match up. Let's take a. We're out of time on this slide. I'm just going to do a quick verification. Now, when x is -2, our y should be -1. So if we plug in -2, indeed we get -1. When x is -3, that's going to be -3 plus 2 is -1. Squared is +1. 2 minus 1 is still 1. Okay. So this verifies our 2 points. Now we could graph and plot points to verify that that's indeed our vertex, and it passes through that point on a calculator. But we'll stop there for now, and we're going to keep moving to the next part.